All right, we are back. So let's look at this one where the factors are repeated. Let's see what we're supposed to do. So when the factors are repeated, but before we do that, let's look at some observation here, all right? The degree of the polynomial at the top is bigger than that of the bottom. And what did I say? Long division. Once the degree of the numerator is greater than or equal to that of the denominator, you start with long division. So by now everyone is familiar with how to do long division. So if you do it, you get your quotient to be x plus 1, and you get your remainder to be 4x. All right. Like I said, please write it in this form, your quotient plus your remainder over the divisor. But notice it, this piece here didn't get any simpler because you have 4x over x cubed minus x squared minus x plus 1. Before you write this, expand this into partial fraction, you need to be able to factorize this bottom piece. So how do we factorize cubic function? All right, if you remember what they taught you in high school, you start by looking for one factor. Once you know one factor, and then you can use long division to get the other factors. You see, we're using long division this question twice. So for this function, if I have to factorize it, I will guess one factor. Most of the time, it won't be a very large number. So you start with 1, you test with -1, you test 2, you test with -2, and you quickly get to a factor, right? We won't give you something that will be so complicated. It's something that you can guess really quick. So if you start with 1, which is your first guess, you get 0. If f of 1 is 0, it means that x minus 1 is a factor, all right? So I use this function and I divide by x minus 1, I end up with x squared minus 1. It means the other two factors is just x plus 1 and x minus 1 because this is difference of squares. So this whole cubic function simplified to this piece here. Everyone knows how we got this. We got this by guess what? By just substituting x as 1 and we got 0. That tells us that 1, so x equals to 1 is a factor that can work. Therefore, x minus 1 is a factor. And through long division, we got this other term here. So we're good to go. Now we can do a partial fraction expansion. All right. Now, let me explain something quickly. So this cubic function, we know how we got this, all right? Remember, x squared minus 1, we had x minus 1 times x squared minus 1. We say it's difference of 2 squared, x squared minus 1 is x plus 1, x minus 1. And if you do that, notice if this and this is exactly the same. So we're just trying to simplify the cubic function as much as possible. You end up with x minus 1 squared times x plus 1. There we go. This is where you now have factors that are repeating because this is in the power of 2. The way it works is, again, it's a linear function. So don't get me wrong, everything inside the bracket is linear. So x minus 1 is linear. Then it's raised to some power bigger than 1. So in that case, we say the factors are repeated, linear functions that is repeated. So in this case, you start with a, again, you're going to use a single constant. So you say a over x minus 1, notice this is raised to the power of 1, x minus 1 raised to the power of 1, b over x minus 1 raised to the power of 2, you stop there. So you start from power of 1, so this piece is raised to the power of 1. You start with power of 1, you go to right up to the power that you see there. In this case, the power there is 2. So we're going to stop at 2. So you see, we only need 2 variables. Then we're good, all right? And then this last term here is just a linear factor again. You just have C. Always assign new constant. Don't repeat them, all right? Use new constant. If you use A, B, go to C. If you use C, go to D, and so on, all right? And then just to explain further, this example that you see here at the top is just for you to understand how repeating roots work or repeating factors. If I have 1 over x plus 2 to the power 4, all right, I'm going to start with a x over 2 to the power 1, d x plus 2 to the power 2, c x plus 2 to the power 3, d x plus 2 to the power 4. Once I see is 4, and it looks like the power that I have, then I know that I have to stop. All right. That's how you deal with repeating factors. Very, very important. All right. So this one here on top is just to explain the concept of repeating factors further. Obviously, everyone knows what to do from this step. Just multiply both sides by these factors here, and then use the technique that works best for you. You can compare the coefficients on the left and the right, or you can let x to be 1, you let x to be -1, and then you let x to be any other constant is going to work. All right. And obviously, once you have the value of your constant, the next is just to integrate now. So in this case, you had a to be 1, b is 2, c is -1. And the integral becomes something easy to work with. So you have x plus 1. That was the,
So,
yes,
sorry, sir, could you please explain the bx plus 1 on top there? I didn't get that part.
bx plus 1.
Yes, it's on top. Like, just scroll up a little bit. Yeah, where there's 4x is equals to ax minus that line there.
All right. So you don't understand where this is coming from. This
Yes,
line.
sir.
So
Yes, and the line before.
you don't, so this one is what I explained from the previous 3 example. You multiply both sides by this piece here. Multiply left-hand side and right-hand side with this piece. So if I multiply top bottom by x minus 1 squared to x plus 1, I'm just left with 4x. On the right-hand side, you have to multiply by this whole thing again. That's how I got a times this, b times this, c times this. So if you take a over x, you multiply by this term here, you'll be left with a times just one of the factors here times x plus 1.
Oh, okay. Now I get it.
All right, and then from there, you just comparing coefficients, or you can choose to let x equate this bottom piece to 0, and then solve for each of those factors. And they say let x equals to 1, you solve left-hand side, right-hand side. Let x equals to -1, or you can choose to just compare coefficients to solve for the constant.
Okay.
All right, so once you have the value for a, b, and c, then it becomes straightforward and easy. All right, notice it again. Your factors were linear factors. That's the reason why you still end up with ln. The person who asks why is it always ln absolute value, because notice it, you have linear factor, you have linear factor. So whenever you have linear factors, you end up with a ln. But be careful to integrate stuff like this. It's not going to be ln. There's a power of 2 there, all right? So it's x minus 1 squared. So it's not ln absolute value of x minus 1 squared, all right? This one, you're going to do a U substitution, you end up with something that looks like this after you integrate, all right? Ln is only when you have a linear function and it's not raised to any power. You see, in this case, x minus 1, in this case, x plus 1, all right? But this one is x minus 1 squared. If you square that out, notice it, you don't get a linear function here, you have a quadratic function, all right? And as usual, just add plus c. If you have ln and you have minus ln, please just simplify it to ln of some function divided by the other function. All right. Now let's keep going. We're going to see a situation now where you have irreducible factors. All right. Irreducible quadratic factors. So what do I mean by irreducible? So if you see factors that look like this, x squared plus 1, x squared plus 4, and so on. All right, so basically, any factor such that b squared minus 4ac is less than 0, we call that an irreducible quadratic factor. All right, and what you see inside this box is for you to remember, all right, because most of you, when you meet something like this, you try to do what we did in the previous section, trig substitution, which is another half page of work. You just need to know this formula. You don't need to show me how you move from year to year. All right, you need to use this. But if you forget in the test, then obviously you have to do a trig substitution, which is done, and you know how long it's going to take you to get to this answer. All right. So this you just need to know, all right, what is in the box. You can just use it to state your final answer. Let's look at this example. Notice it. The power there is lower than the power at the bottom. So what comes to mind? Partial fraction. All right. Now, if I try to factorize this bottom piece here, x cubed plus 4x, I take out an x, I'll be left with x squared plus 4. You see, we have this irreducible quadratic factor there. We have a linear factor, but we also have an irreducible quadratic factor. For the linear factor, you already know what to do. When you're dealing with partial fraction, you just assign a constant, so a over x. What do you do for irreducible quadratic factor? You need to include a variable. Very, very important. You must include a variable. So you say bx plus c. All right. So take note, you will move from a constant because it was a linear factor. When we hit a quadratic irreducible, we move to linear term there at the top. All right. From constant, we move to linear. All right, which is bx plus c. Let's assume that this term here was raised to the power of 2, the quadratic term. Do you agree? You're going to continue. So you're going to say plus. You're going to have, since you've already used the constant a, b, and c, you're going to say dx plus e divided by this same piece here at the bottom, be raised to the power 2. That's just the case where this was raised to the power 2. Hence, you can have a combination of linear factors, irreducible quadratic factors, and then factors that are repeated. So all of that can happen within the same function. And take note of that because that is what we like testing most of the time. All right, let's scroll down so that we see. So it's the same idea. You multiply both sides by the factors there at the bottom. Solve for a, b, and c. And then I'll show you something quickly. So when you solve for a, b, and c, remember, if you plug in the constant b and c there, you get something that looks like this. Please, when you hit this step, don't panic. Because you ask yourself, what do I do? It's not a use sub, it's not a trig substitution. First thing that should come in mind is just split it into 2, all right? It comes from the fact that if I have a plus b divided by some common denominator c, I can split this into 2, all right? So you can have a over c plus b over c. All right, so that's the whole idea there. Please remember this trick. It's going to help you many times. So if you have something like this, just take x over this common denominator minus 1 over this common denominator. Then it becomes something easy to work with. Now, how do we integrate this? It's just laying absolute value of x. That is straightforward and easy. This one is just a u substitution. If you let u to be x squared plus 4, it works because there's an x there at the top. It will cancel with du. This one, I gave you a formula which you need to remember. Remember that formula that I showed you earlier? It's just 1 over the coefficient of x here, tan inverse of x over the coefficient of x. So remember that formula there in the box. If you forget the formula, then you know that this is trig substitution, where the trig substitution there is going to be tan. All right. But I'll prefer that you remember the formula I gave you because trig substitution is going to consume a lot of your time in an assessment. All right. All right, there's some homework there. So I give you an homework. Quickly, I need someone to be bold enough to write there or to tell me, what do I do with this question? Can someone tell me quickly? Just by looking at it, what's the first step? Can someone tell me quickly what's going to be done in this question? Someone say factorize, yes. Obviously, we always need to factorize the bottom piece if we have to use partial fraction. But what is the really first step? By looking at it closely, what do you observe? Long division, good, because you can see that the degree of the polynomial at the top is equal to that of the bottom. You can see I say homework with exclamation mark means you need to be careful with this kind of example, because when most of the time you guys, you forget the fact that the powers can be the same, and then you ignore long division. You ignore long division, you're going to lose a lot of marks, all right? Everyone is happy with that homework. And then let's see what comes next. Now, example 7. This is, I would say, multiple choice example where I ask you, okay, just write out the partial fraction decomposition. I don't necessarily want you to solve the constant, just to write them out. All right, let's go through it step by step. You should be able to do stuff like this. All right, the first one is a linear factor, so we're happy. It's just a, you assign a constant a here by x. Again, we see another linear factor, we go to b. Now we have a quadratic factor. You must check, always check, what is b squared minus 4ac? All right, so you check b squared minus 4ac. If you try that, notice it's going to be less than 0. That is when it means it is irreducible. Irreducible quadratic factor. Why? Because b squared minus 4ac is less than 0. In other words, you're not going to get any real roots if you try to solve for that, for the quadratic function equals to 0. You wouldn't have any real roots, all right? You have complex imaginary. So because it's irreducible, what comes to mind? Linear term at the top. Linear term means I have a, b, and it says cx plus d. This is linear, cx plus d. So there must be a variable now appearing at the top, the variable x. Now let's look at this one. Again, if you use b squared minus 4ac for this quadratic term, you notice that it's still less than 0. So you still have an irreducible quadratic factor. But take note, it's repeated, it's to the power of 3, right? So it means we have a, b, c, d, we move to e. So ex plus f, remember this is raised to the power of 1 there at the bottom. You keep going, gx plus h, x squared plus 1 to the power 2, ix plus j, x squared plus 1 to the power of 3. Remember, once it's raised to the power of 3 means we need to see 3 different terms, all right? And because it's irreducible, it means you're going to have linear function in all of those cases at the top. Please use different variables or different constant, all right? The variable remains as x, but use different constant. So you see I move from A, B, C, D, E, F, G, H in that order. I don't want to see a C here. For some reason, I see a C appearing somewhere. Automatically, if it's a question that you have to solve for the constant, the constant is going to be wrong because you're using the same constant, all right? So that was a quick question that we can ask you for MCQ. So watch out for stuff like that. All right, another one is something like this. X cubed plus a. You can write it as x cubed plus the cube root of a cubed. If you check, I think at the back of your textbook, these formulas are given to you guys. The difference of cubes and so on, the sum of cubes. All right, so remember those formulas, they're going to help you a lot as well. All right, substitution by rationalizing. Now, this is usually the complicated. It's not supposed to be complicated, but you guys make it always complicated. The one that students usually get 0, all right? Is substitution by rationalizing. All right, some functions can be changed into rational function by means of a substitution. So I give you an integral. Looking at it, you simply have no idea what to do because there's a root there. It's not a rational function where you're going to do partial fraction and so on. However, using an appropriate substitution, you can transform this integral into a rational function. Once you get something to a rational function, you know already you can do partial fraction. All right. So let's see, for example, this first one, how it works. So I give you integral square root x plus 4 by x, all right? You let u to be this root here at the top. So root x plus 4. If you square both sides, u squared just becomes x plus 4, all right? Why am I making this substitution? Take note, at the top where I see this root, I'm just going to have u. This is a u that you see there, all right? And then at the bottom where I see x, Yes, I know the x is going nowhere because it doesn't cancel with du. However, from this step here where I squared both sides, I can make x a subject. So I end up with u squared minus 4. All right. And then we know what dx is. Dx is just 2u du. How do I get 2u du? Remember, if you differentiate in both sides, you differentiate implicitly. All right. You remember your implicit differentiation. So you say 2 times u du, all right, because it's a u squared. So you differentiate implicitly. There you go. And if you do that, you end up with u squared over u squared minus 4. Now I need someone brave without looking at the lecture slide to tell me what do we do with this piece here? How do I integrate u squared over u squared minus 4? Yes, it's a polynomial, so it's a rational function, but what do you observe? Long division again, yes. Why? Because you can see the power there are the same. It's u squared, at the bottom you have u squared. Please, if you remember this, you're going to have so much marks in your test, all right? If you remember this little trick. So you're going to start with long division. I'm just going to clear it and scroll down so that you see the long division. If you do long division, notice it, you just get 1 there at the top, and your remainder will just be 4, all right? And obviously, just get my notation again. So if you do long division, you have 1, the remainder is 4. So remember, you write it as 4 over the divisor, which is u squared minus 4. This piece here, we need to do partial fraction because you can't integrate this directly. You need to do partial fraction. Difference of 2 squared means you have u plus 2, u minus 2. This is straightforward. It's just a over u plus 2, b over u minus 2. All right. There's no order in this thing, guys. A, B. It's nice to just go in that order, A, B, C, D, and so on. Someone can say b over u plus 2 and then a over u minus. It's fine as long as it's a constant and they're different. It works. It will give you exactly the same final answer. But please, just for consistency's sake, just keep it in that order. Start with A, move to the next letter B, C in that order. All right. Don't start in reverse order. And obviously, everyone can solve for A and B. And if you do that, then it becomes easy to integrate. Notice it, A is minus 1, B is 1. And then the integral is just a ln absolute value as usual. But now be careful, I'll explain something. You see at this step here, your final answer is in terms of u. But remember that I gave you the integral in terms of x. So always check. Whenever you solve an integral problem, ask yourself, is this final answer in terms of the variable that I started with? If the answer is no, it means you need to make a substitution. What was the substitution we made? We said u was root of x plus 4. That's why you see everywhere I see you, I just put root of x plus 4. All right. And there you go, you're done. It's as easy as that.